Now, let's add on to our trigonometry notes, and we're going to look on page 80 of the trig notes today to fill in this example. And they want us to find tan A, sine A, and cos A if we know sine of the double angle. So the first thing you're going to want to do is go and look in your log tables and see if you can find any formula that relates sine of twice an angle to something that just has the angle on its own. Now, when you look in your log tables, you'll see that sine of 2a can be written as 2 sine a cos a. But that's not very helpful because I have two unknowns. There's two things I don't know there. So it doesn't help me. But you might, when you look through all the sine 2a options, you'll find this one. Twice tan of a divided by 1 plus tan squared of a. Okay, I really just have one unknown here. I know it kind of looks like one of them is squared, so there's only one variable in this. So I'm going to use this here. But I'm going to go a little bit further, and I'm going to use a single letter, x, to represent tan of a, just to make my algebra a little bit neater while I'm working. So that means, of course, that x squared will be tan squared of a. And what we're going to write down is that sine of 2a is equal to 2x over 1 plus x squared, and that's equal to 7 over 25. And now I can solve this. And when I've solved this, I will have tan of the angle because x is tan of a. So once I find x, I'll have tan of a. This is two fractions either side of an equals, so I can cross multiply. That gives me 7 bracket 1 plus x squared equal to 25 by 2x. I multiply out my brackets, and then I will bring everything to one side. 7x squared minus 50x plus 7 equal to 0. There could be factors, but let's just use the minus b formula. So x will be minus b plus or minus the square root of b squared minus 4ac all over 2a. And we'll pop that into our calculator in one go. Minus 50 squared minus 4 by 7. They were both plus, weren't they? By 7. Okay, so I get 48. So there were factors because the fact that that came out as a whole number meant that there were factors, but sometimes it's just as easy to go with the minus b formula. X is equal to 50 plus or minus 48 over 14, my plus answer and my minus answer. You notice we're getting two questions here, and we maybe weren't, or two answers here, and we weren't expecting two answers. The question didn't say values or anything like that. Let's see what we get. So if you plug in the plus, you get x equals 7. And if you plug in the minus, like this, and we get x equals 1/7. So we've got two different values. It turns out we get the same answer. What happens is, and I'll leave it up to you guys to try this yourselves. Cos and sine are swapped around. That's what that means. Okay, so we have x equals 7. Let's just go with the x equals 7 at the moment. So x equals 7 means tan of my angle is equal to 7. So that's one of the values. Now, how do I find the others from this? Well, if I do a right-angled triangle, tan is opposite over adjacent. So, not a great diagram. 7 over 1. I can use Pythagoras' theorem to find my hypotenuse. So h squared is 7 squared plus 1 squared, and that gives me 50 So h is the square root of 50, which is 5 root 2. 5 root 2 here. And now I know that sine of my angle is opposite over hypotenuse, which is 7 over 5 root 2. Let's write that down nice and clearly. 7 over 5 root 2. And cosine of my angle is adjacent over hypotenuse, which is 1 over 5 root 2. Okay, so that's how you use the right angle triangle. You could have used tan inverse, gotten the angle. You'll get decimals then because you'll end up having a rounding error. So this is how they expect you to do it, but if they haven't specified, you can get full marks even if you have decimals. Right, I said what will happen if we use x equal to a seventh is that these values will swap around. So let me show you. So if x was a seventh, then tan of my angle will be 1 over 7, and that is opposite over adjacent. So again, my angle is down here. The 1 and the 7 have swapped around. My hypotenuse is still going to be 5 root 2 because x squared plus y squared equal to h squared. So that means that sine of my angle, opposite, adjacent, if you're not clear, opposite over hypotenuse will be sine of my angle, which is 1 over 5 root 2. And adjacent over hypotenuse will give me cosine of my angle, which is 7 over 5 root 2. So those are the two sets of answers that we could have had. You can see that what's happening here is that we don't know whether this was my angle or this was my angle. So that's where that's coming from. Okay, difficult kind of question. I still don't want to spend a lot of time on it because, as I've said a few times now, these don't come up very often at all. So we don't want to spend a lot of time on them, but we do need to see them. Okay, so thank you.